Hello everyone. So the question is, the key features of Bohr's spectrum of hydrogen atom is the quantization of angular momentum when an electron is revolving around a proton. We will extend this to a general rotational motion to find quantized rotational energy of a diatomic molecule, assuming it to be rigid. The rule to be applied is Bohr's quantization condition. In a CO molecule, the distance between C, mass is equal to 12 AMU, and O, mass is equal to 16 AMU, where 1 AMU is equal to 5 upon 3 into 10 minus 27 kg, is close to, and we have given 4 options. Now we have to find the correct one. So now we have to find the distance between C, O molecule, where mass of C and mass of O is given. And also we have the value of 1 AMU. Now for that, let's say that this is the bonding between C and O. Okay? And let us mark this distance as D distance. Now we know that O is heavier than C. So the center of mass of CO molecule is somewhere to the oxygen. So for that, let this point be the center of mass, and let this coordinate be 0, 0. Now let us mark this distance as R1 and the another distance as R2. Now we can write this as Cm is equal to M1 R1 minus M2 R2 upon M1 plus M2, as this one is 0, 0. We can write this as M1 R1 is equal to M2 R2. So by this we can write that R2 is equal to M1 upon M2 R1, right? Put the value of R2 in the terms of D, as we have to find the distance between CO molecule. So R2 is D minus R1. So by this we can write that D minus R1 is equal to M1 upon M2 R1. So we get the distance as D is equal to 1 plus M1 upon M2 into R1. Now we have to find the moment of inertia. For that we can write that I is equal to, for that we can write as I is equal to M1 R1 square. For that we can write that I is equal to M1 R1 square plus M2 R2 square. That will be M1 plus M1 square upon M2 into R1 square. So by this equation we can write in term of D that M1 plus M1 square upon M2 upon M1 plus M2 the whole square into D square. Now we can write this one as m1 m2 plus m1 square upon m2 into m2 upon m1 plus m2 the whole square into d square. m2 and m2 will cancel. So we can write this as m1 m2 into m1 m2 upon m1 m2 the whole square into d square. Now we can cancel this one term of m1 and m2. So our I will be m1 m2 upon m1 plus m2 d square. Now we know the moment of inertia I is equal to 1.87 into 10 to the power minus 46 is equal to m1 m2. What is the value of m1 and m2? C and O, that is 12 and 16. That will be 12 into 16 AMU square upon m1 plus m2, 12 plus 16, that is 28 AMU d square. We can cancel this 1 AMU, that will be 1.87 into 10 to the power minus 46 is equal to 12 into 16. Now we are left with 1 AMU. The value of AMU is 5 upon 3 into 10 to the power minus 27. So we can write this as 5 upon 3 into 10 to the power minus 27 upon 28 d square, right? Now after solving this whole term, we will get d square is equal to 1.63 into 10 to the power minus 19. So after solving all this, we will get d is equal to 1.3 into 10 to the power minus 10. Now, which one is our correct answer? That is C1. 1.3 into 10 to the power minus 10 m. That is the answer. Thank you.
Hello, we are given with a question, and the question says when a particle is restricted to move along x-axis between x equals to 0 and x equals to a, where alpha is in nanometer dimension, its energy can take only certain values, specific values. The allowed energies of the particle, this is x equal to alpha. Right, energies of particle moving in such a restricted region corresponds to the formation of standing wave with nodes at its end x equals to 0 and x equals to a. Right, so we have nodes, correct? So that means this value alpha, right? So alpha would be equal to n lambda by 2. It would be integral multiple of lambda by 2. The wavelength of the standing wave is related to the linear momentum p of particle according to de Broglie relation. So we have de Broglie wavelength, that is lambda, to be equal to h by p. Right, so what we can do is we can substitute this value. So from here lambda would be equal to 2 alpha by n. So from here what we can say is that is 2 alpha by n equals h by p. Correct. So from here we can write p to be equal to n h by 2 alpha. Correct. Now what we are given, the energy of the particle of mass m is related to its linear momentum as this. So energy now is related to p square by 2m. Since this is given, so this implies that energy would be equal to n square h square by 4, not 4, actually 8. 2 into 4. So that is 8 alpha square m, right? So the energy of particle can be denoted by a number n taking value 1, 2, 3, right, corresponding to the number of loops in the standing wave. Use the model described above to answer the following 3 questions for a particle moving along the line from x equal to a to x equal to alpha. H is this and E is this, the value. So the allowed energy for particle for a particular value of n is proportional to, so since we have H to be the constant, right, m is constant for a given particle, n is fixed as we are given that value of for a given value of n, right? So what we can write, for given value of n, energy is proportional to, 8 is also a constant, 1 by alpha square. So that means energy is proportional to alpha raised to minus 2. So our answer is alpha raised to minus 2, option A. Thank you.
When a particle is expected to move along x-axis from x equal to 0 to x equal to a है यहाँ पे, where a is a nanometer dimension, its energy can take only a certain specific value. The allowed energy of the particle moving in such restricted region nodes at its x equal to 0 and x equal to 8. कह रहा कि the wavelength of the standing wave related to the linear momentum p of the particle according to de Broglie relation. The energy of the particle of mass m is दिया हुआ है आपको E equal to p square by 2m. ये काइनेटिक एनर्जी दिया हुआ है, ठीक है. Thus the energy of the particle can be denoted by a quantum number n का वैल्यू दिया हुआ 1 2 3. 1 कह रहा है ग्राउंड लेवल स्टेट है, ठीक है. तो use the model to describe above the answer and allowed energy of the particle value of n is proportional to. मतलब ये कह रहा है कि जो एनर्जी है वो एनर्जी ई यहाँ पे जो है किसके प्रोपोर्शनल है, आपको एक ए स्क्वायर है, ए की पावर माइनस 2 है, किसके प्रोपोर्शनल हमें निकालना है, ठीक है. तो हमें पता है ए इक्वल टू क्या होता है, एन लैम्डा बाई 2, ठीक है. तो लैम्डा इक्वल टू कितना हो जाएगा, 2a बाई एन. एनर्जी है एन, क्या कह रहा है कि एन लॉर्ड एनर्जी फॉर द पार्टिकल वैल्यू ऑफ एन इज प्रोपोर्शनल टू, मतलब ये जो दिया है ना क्वांटम नंबर एन वो बता रहा है, ठीक है. लैम्डा इक्वल टू डी ब्रॉगली वेवलेंथ कितना होता है, एच बाई एम वी होता है, एम वी. और एम वी क्या होता है, मोमेंटम होता है, एच बाई पी लिख सकते हैं इसको. लैम्डा इक्वल टू हो गया 2a बाई एन इक्वल टू एच बाई पी. पी इक्वल टू क्या हो गया, एन एच बाई 2a. ई इक्वल टू क्या होता है, पी स्क्वायर बाई 2m होता है, ठीक है. तो कितना हो जाएगा, एन स्क्वायर एच स्क्वायर डिवाइडेड बाई 8a स्क्वायर एम आ गया, ठीक है. तो यहाँ पे क्या कह रहा है कि द अलाउड एनर्जी ऑफ पार्टिकल वैल्यू ऑफ एन, मतलब कोई पार्टिकुलर वैल्यू ऑफ एन, मतलब एन तो कांस्टेंट होगा कोई पार्टिकल वैल्यू पे, एम भी कांस्टेंट है, एच क्या है प्लैंक्स कांस्टेंट है, ये भी कांस्टेंट है. तो यहाँ पे वेरिएबल कौन है, डिस्टेंस है. तो ई इज इनवर्सली प्रोपोर्शनल टू 1 बाई ए स्क्वायर हो गया. तो ई डायरेक्टली प्रोपोर्शनल टू क्या हो जाएगा, ए की पावर माइनस 2. तो कौन सा ऑप्शन हो जाएगा हमें यहाँ पे देखिए ऑप्शन, तो ये वाला हो जाएगा ऑप्शन ए की पावर माइनस 2.
Hello students, our question is, in a mixture of hydrogen helium positive gas, helium is singly ionized helium atom. H atom and helium plus ions are excited to their respective first excited state. Subsequently, H atoms transfer their total excitation energy to helium plus ions by collisions. Assume that the Bohr's model of atom is exactly valid. The quantum number n of the state finally populated in helium plus ions is. So solution for this will be, if we talk about Bohr's model, En is given by 13.6 minus 13.6 z square divided by n square. So if we talk about hydrogen atom, for hydrogen atom, so energy for first level is minus 13.6 electron volt. For second is minus 13.6 divided by 4, which is equals to minus 3.4 electron volt. So change in energy will be equals to E2 minus E1, which will be equals to minus 3.4 plus 13.6 electron volt, which is equals to 10.2 electron volt. Okay. 10.2 electron volt. Now, if we talk about helium atom, helium positive atom, so its excitation state is E1 is given by minus 13.6 into 4, which is equals to minus 54.4 electron volt. E2 is equals to minus 13.6 divided by 4 into 4, which is equals to minus 13.6 electron volt, and E3 is equals to minus 13.6 divided by 9 into 4, which is equals to, and E4 will be equals to minus 13.6 divided by 16 into 4. So this will cancel out. So on solving, we will get minus 3.4 electron volt. And if we solve this, minus 6.04 electron volt. So it means transition is up to 4th energy level. So if the quantum number n of the state finally populated in helium plus ions is 4th. So option 3rd is our correct option, which means 4 is correct answer.